I'm going to talk about the different architecture patterns well known in the software industry. I'm going to start from the old ones, walking through the more recently and used in the software industry. For each pattern, I'm going to explain what is the goal of each pattern and what are the strengths and drawbacks for each pattern. It's important to mention that you can enter to a software when you can find a mix of different architecture patterns. For example, you can enter in a system when the monolithic architecture is well known, but there are functionalities that work more like a microservice architecture. It is common to find a project working like this in the software industry. But it is important to know each software pattern because you can take more useful an informed decision about how you tackle different requirements in the software. With that in mind, let's start with our first software architecture pattern. The monolithic architecture is probably the most known architecture pattern in the software industry. In this architecture, you have all your components in the same place. For example, you have the user interface, business layer, and data access in the same place. This is easy to start a project, but in the future it could be a nightmare. For example, if you need to do a change in your code, you can break another part of the software or another functionality. Another drawback for this architecture is the teamwork. When you team member make a change, he could break another part of the software, and for that reason this architecture is not used in the large project or medium project. This is for a small project or for demo, and with that in main, we need to create or use another software pattern. Let's continue with another software pattern. The MVC software pattern, the model view and controller pattern, is used for small and medium software. The main idea for this pattern is to have a controller that receive all the requests from the view, and the view can in another language or another component, and with that request the controller update or the entire model, and the model, with that model updated, the controller return the request to the view. And this pattern is used in the Spring MVC, and Spring, for example, give the MVC a starter to develop this architecture, because with the started MVC we can define the REST controller and the REST mapping to our controller and call the model. With that in mind, let's continue with another software pattern. But first, I need to say that this software pattern is used in a small and medium project, because when you have the controller that have a lot of code, a lot of functionality, it is very hard in the future to modify the controller. Let's move it to the another one. The layered architecture pattern is a pattern to aim for more organized layer in the software. In this architecture pattern, you have the layer of the presentation in the first place. Second, you have the business layer. Third, you have the persistence layer, and then the database layer. You can have more than this layer in your system, but if you have more or an excessive layer, you finish it with a problem in your system, because it could be slow when your user requests and need to walk through all the layer in your application. For that reason, it is good to know that its architecture pattern is well organized. You can maintain this pattern or this architecture in an easy and efficient way. But in the future, if you have many layers, it could be difficult for the maintainability and for the speed of your system. Let's move to another architecture pattern. The micro front-end pattern is more for big systems. This pattern is used regarding to the different views of the application. For example, you can have the view for a client, another view for the customers, and this view could be deployed in different teams. For that reason, this is used for large teams, because every front end is independent from the other one. In this architecture, you can have different data layers, or you can have a central data layer. And the micro front-end architecture pattern is used for large teams, and could be complex to maintain in terms of the cost of the development, but it works nicely for a large software, because the changes in one module or front-end module is not affected, or it not affected to another front-end module, and it is good for the reliability of the software. Let's continue with another software pattern. This one is a modern software pattern. It is the hexagonal architecture, and this is more to have a centralized business logic, and this business logic is accessed from different parts or using the ports. And in this example, you can see in the middle of the architecture the business logic, and in the different layer or different part of the software, we will have the different ports to connect to different adapters. For example, in the top right of this diagram, we have the business logic in the center, the port to access or to the ORM, and the ORM adapter. These communicate a portion of the data with the business logic, and we can have another port, for example the port for UI and the adapter for the UI. This port access to the business logic and send to the user the information required for the user. Let's move. This architecture pattern is useful for large teams, and this aim for the flexibility and adaptability to different parts or logic of the application, and have, of course, the logic centralized in one place. Continue with this SOA architecture pattern. This is for the service-oriented architecture pattern, and the main goal, or it used when we have in the middle an enterprise service bus, and this ESB receive all the communication from other system throughout messaging, and with this communication, this allowed to the company to integrate different systems, no matter if the system that are integrated is in different language or are legacy. And for this reason, this is a good architecture pattern for big company that have a lot of softwares integrated with other outside or inside the company. And the ESB could be become a bottleneck, because when this fail, the entire system fail. And for this reason, generally we have a redundancy system. When this ESB fail, we can have another ESB to receive the message from the application. Continue with another software architecture pattern. In this architecture pattern, you have different pieces of your software. In this example, we have 3 microservices, and 2 clients communicate with these microservices. For example, if we have an order microservice and we have another microservice payment, these 2 services could be accessed from the client in the different network and in the different platform or infrastructure. With that, I say that you can deploy the order microservice in different way that payment service, and you can have different database for different microservices. For example, in the same example, you can have a database in MySQL regarding to the payment orders, and you can have a Cassandra database for the orders. It could be perfect in the system. This architecture is for big companies because the maintainability is complex, because you need to maintain different software or different microservices for each flow or for each service. And with that, I'm going to continue with another microservice pattern. This one is the event-driven pattern, and in this pattern we have in the middle the event broker. A good example of this event broker could be Kafka, and in this software pattern, the main goal is have a producer and consumer, and the producer send message to this broker or event broker, and this event broker send this message to the consumer. This architecture pattern have multiple advantage. For example, in the term of the reliability, because when you your consumer fail, you have another consumers that can read the events in the event broker. This event-driven architecture pattern could be complex in terms of maintainability and testing, because you need to track the message to perform a test. And one useful strategy to track this message is to assign an UID to each message, and you can track each message throughout the flow of the event broker. You can track the message when the producer sent to the event broker, and you can track the message when the consumer process this message. Finally, we have the master and slave architecture pattern. In this pattern, the main goal is that you have a master, and this master direct the flow or direct the tasks that the slave need to do. The master direct what or define what task should be done, and the slaves done or performed the required flow to accomplish this task. There are the useful or more useful and known software pattern in the software industry. Next, I'm going to continue in the hands-on modifying our example application for the reservation. We currently, how you can see, or if you can check, we have the MVC pattern, design pattern implemented currently in our example. Now I'm going to move to the layer architecture pattern, because this architecture pattern I'm going to explain more in depth about the best practice that should be followed in the big software.